All right, we're live. Hello, everyone. Welcome to IBM Developer Online Meetup. My name is Lubkar. I'm a developer advocate at IBM. I'll be your host for today. I hope everybody's doing well, keeping safe. Thank you for spending your time with us again. I see some familiar names in the audience, so welcome back. And for those of you who are here for the first time and new to IBM Developer, we are a team of developer advocates from across the world. We host mostly online meetups and workshops these days, but hopefully we'll go back to hosting in-person workshops with very amazing food and drinks. So we do
I
a lot
definitely
of
miss
developer.
that.
I think you do. We do a lot of developer education events, right? So that's what we do. Today, as you can see, I have our wonderful developer advocate, Billy Corando. Hey, Billy.
Hey, how's it going,
So
Luca?
good. I'm a big fan, right? So Billy does a lot of stuff, stuff, and works extensively with Java. And so I'm super excited to have you on, Billy, and tell us more about what contract-driven development is, how does it fit into TDD and testing and all that good stuff. Before I hand it over to you, I do want to lay down some house rules here. So first, I see you're using chat, which is amazing. Please keep doing that. Say hello to us, to your fellow audience members. If you have a question, you can put it in the chat, or you can put it in the ask a question button. So you can use that to ask a question. Billy may not be able to see the questions, but I'm moderating today. I can, if it's very urgent, I can interrupt Billy, or we can answer it at the end. However, we'll keep it casual today. Hey, Alan, good to see you again. All right, so I think with that being said, Billy, I'll pass it over to you. And I'll go off screen, but I'll be in the background if you need me.
Right. All right. So yeah, thank you for that introduction, Ukar. And I will try moderating. Like I have the chat window open on my screen over here. But yeah, definitely feel free to ask questions at any point. I'm here to help you learn about contract-driven development. And otherwise, yeah, definitely, Ukar, like there's a question that I'm just not noticing, definitely feel free to let me know so I can get those questions answered. So as you probably mentioned, I'm a developer advocate with IBM. I focus on Java, and then within Java, I kind of also focus particularly on Spring because that was my background before I became a developer advocate. I worked for about a decade as a developer doing a lot of Spring work. If you have any questions, definitely reach out to me on my Twitter, or feel free to email me at william.crandall@IBM. And my Twitter is always open to DM. So if you have any questions or anything, definitely reach out. I'll be more than happy to answer them. So with that said, let's go ahead and get into this presentation. So what is contract-driven development? So it's not really particularly new, but that said, it hasn't really penetrated the software development ecosystem that deeply. At least in my experience, very few people know about it, very few people, and even less actually do contract-driven development at their work. So let's kind of at least get like a very high-level overview of what contract-driven development is, just so you can kind of understand, get in that headspace of it, and then we'll actually go into much more depth and detail later on. So at a very high level, contract-driven development is defining the behavior of the API in a way that can be programmatically tested. So you have a client, and they send in a request, and that request is going to go to like an endpoint, and that request is going to have, if it's like a post or a put, it could have some sort of body. It's going to maybe have some headers, like an authorization header, and so on. All the same, a request is going to have a certain composition, and it's going to send that to the service. So yeah, it sends that off to the service. And then based upon what that request looks like, the service should respond in some way. It should give, hopefully a 200 response back. And it's some sort of information back within that request or the response body based upon what the client says or what the client sent. And so what contract-driven development is writing this out in quote-unquote contracts that define this actual behavior that can be tested against. That's the basics of it. So with that said, a lot of times I've gone to presentations where a new concept or methodology or technology is described, but sometimes it can be hard to relate to like how it could actually help me at my job. And I kind of think about this scene from It's Always Sunny in Philadelphia, where one of the characters, Charlie, is seen taking a bag of trash through the bar that they all own. And he says he's going to burn it where it's going to become stars instead of putting it in the ground where it's just going to stay there for thousands of years. And one of the characters is like, that doesn't sound right, but I don't know enough about stars to really dispute it. So kind of with that said, let's kind of look at some of the problems that at least relate to like my experience as a developer that kind of happen when you don't do contract-driven development. So the first scenario I kind of was thinking of is a existing but poorly defined service out there. Just like some existing service you just have to work with to get something. In this case, I kind of just say, for example, customer information, but it's just not that well defined. So let's kind of actually look at this little scenario. I like to put together funny little GIFs on how this would kind of maybe work out. So yes, you need customer information. They want to use the customer API. So you, the client, developer, going to work with it. Well, did you read the documentation? It's in a Word doc. Okay, call get customers to get all this info. So HTTP get customers, but it's actually a post endpoint. You said to call get customers, get nothing back, 405. So you should use the post. So a post happens, and it's still getting nothing back. Oh, you forgot to send the auth Z header, not documented, still getting nothing back. And now that service fails. And what went wrong? Oh, well, the database behind that service that you're trying to call, it was down for maintenance. Eventually, it sends maybe back like a 200 response, but with the error code within it. But what that error code means isn't really defined anywhere. So you really have a hard time understanding what's going on. I've worked with many services like this throughout my career. So what do we have? Well, we have a poorly defined or undocumented API. Maybe the API, like the documentation just said call get customers, but it never specified post. So you just kind of assume it's a get, especially since you're just getting information. So that's confusing. And maybe it's undocumented in that like it doesn't say you need to send like an authorization header. It doesn't explain maybe what the error codes mean and stuff like that. So we have a poorly defined or undocumented API. It's also maybe defined within like a Word doc or PDF, which also isn't always the easiest thing to kind of work with as a developer. We can also see it has inconsistent behavior patterns. Again, maybe you should or shouldn't follow full RESTful development, but when you see an endpoint called get customers and all you're getting back is customer information, you would maybe generally expect that to be an HTTP get, not an HTTP post. But again, I've seen many places where everything's considered a post or something like that. So it can just maybe, again, be confusing for a developer to look at and work with. Also, you have an issue when you're testing against live services that can lead to inconsistent results. So in this case, in the example I had, like you're trying to call a service, but then that service is down because like a database is down, data may be missing, it may be down for maintenance, or it could be any number of things. And so what's confusing then as a developer, maybe you finally think you have everything working, but then it fails and you're now making more changes to trying to get it working when it's not you're doing anything wrong, it's that service was down. Within a broader, more automated testing environment, you may start losing faith in your automated test because they're going to say, hey, this test failed. You investigate it and you find out that actually there's nothing wrong with the test. It's just the service you're testing against went down or, maybe data went missing. So you start losing faith in your automated test. You start ignoring them or something like that. And that's not good. That kind of make it hard to do things like CI/CD because you can't really put much faith in your test because they may be failing for no particular reason. So that's one particular problem maybe with not doing contract-driven development. Let's look at another one. So another potential scenario or problem is, okay, you've been in a bunch of design meetings and you're building out either a completely new service or adding a new feature to an existing service. All the same, but kind of adding something new. You're doing new developments. But one kind of problem is often you have to do things in a very serial format. So you went through all these design processes and you're kind of ready to begin, perhaps you as a client-side developer, but now you have to kind of wait. And so you have this very serial development. So let's kind of maybe look through some of the issues with that. So like I said, design meetings, and now the service, all right, everyone freeze while they write the service. And it's this older endpoint ready. Well, no, they had to make a change to that endpoint. Do you know when the API will be finalized? Well, they're making some more model changes to it as they're figuring some stuff out. And now that service developer just got pulled into a production issue. And so no one else is there to work it. So like order summary, all these different features that you want to work on, they're kind of frozen in place until that service developer has time again to actually devote to working on the development. And so what we have here is kind of like an inability to develop in parallel. The client developer will have to wait until that service developer is done or near done with their service before they can really begin. At least kind of what I have found when you try to maybe work in parallel, maybe that client developer tries to, on their own side, kind of mock out what they think the service is going to look like. But the problem there is it's what they think it's going to look like, and it might actually differ somewhat from what the real service looks like. I remember distinctly one time trying to do this, and I kind of changed like the depth of what the response would look like, and then also maybe some of the field names. So like instead of first name, last name, middle name, like I think it did F name, L name, M name for like some of the name fields. And of course, the client developer was expecting something different. It's a minor difference. It could be kind of easily worked over, but it's just kind of one of those examples where the client developer, maybe it could have been like a more significant change, like a whole model change, or how I just defined the services and endpoints work very different what they're expecting. And so really all the work they did has to kind of be thrown out or significantly rewritten to actually use the service. And that can kind of just lead a lot of times client developers just to kind of wait until that service is ready before they begin their work, because otherwise they may have to spend a bunch of time just throwing away work that they already did. Also, when you have a serial development, you have timeline impacted by delays from both the service developer and the client developer. All developers could get pulled in production issues. All developers can get sick, go on vacation, so on. And so when you're not working in parallel, any sort of delay there, that's going to impact the overall timeline for when a new feature or service or update could be made. And that just kind of also happens a lot with software, where it's like, oh yeah, that will take a week, and it ends up like taking 2 or 3 weeks because you get pulled into production issues or something takes a little bit longer to figure out. Whereas within the kind of working in parallel, it's a little bit, if one side gets a little bit delayed, it's not going to immediately impact the other side in the overall timeline. So there's a little bit more generous and are forgiving when it comes to timelines. Also, the last kind of issue is when a client developer kind of decides, okay, I'm just going to wait until that service developer is ready. That may take a week, may take 2 weeks, it may take longer before that service is ready to actually be worked on by the client developer. And in that time, that could be like 3 production issues ago, 10 tickets, all these different things. And you may have completely forgotten how you're actually going to approach and work on this new service. And so it's going to maybe take you a couple of weeks, or maybe not a couple of weeks, but it takes you some time to kind of get back up to speed on how you're actually going to figure out how you're going to actually design this new feature or consume with this new service. And so the last scenario I kind of want to maybe go over is like you have this actively worked on, actively used service, but then it might get changed. You might have an enterprise developer like myself who maybe kind of from that first scenario see something like API GET customers and think, hey, that's not properly RESTful. I'm going to go in there and change that and make it properly RESTful because, I'm all about best practices or something. But, maybe, so I do that, but I don't tell anyone else. And it's like, oh, okay, so service developer, I just changed this API to be API customers, and no one told the client when it to go to prod. Oh, I deployed it last night. Well, at least the client developer knows all this production issues is going on, but they'll be staying late to update that. Oh, and by the way, I also made some changes to the customer model as well. Have fun. But kind of what happens here is sometimes like the service developers, maybe they don't communicate well and they just decide to kind of make some changes. Maybe the changes could be good, they could be bad, but the same, they're kind of being made and there's no real way for client developers to know, and maybe QA didn't know about it, or no testers kind of knew about it, so it kind of gets to production without anyone knowing. So yeah, breaking API changes may not be caught until they get to production, and of course, having production go down is never a good thing. That, obviously causes a lot of problems. Another issue is that service developers, well, because they're actually writing the service, they kind of can decide what the API is going to look like. You can maybe have some design meetings, but ultimately, they may kind of write things that kind of best suit their development paradigm or what they think API should look like. And maybe the client developers don't really get much say in it because they can't really have any way of pushing down changes by the client developers. So those are some of the issues that you can kind of experience when not doing contract-driven development. Again, I kind of remember some of these, running into all these issues at some point or another in my career before I became a developer advocate, and just being kind of frustrated by them. So let's actually get into more depth with contract-driven development. And for this, there's many different options for doing it, but I'm going to demo it using Spring Cloud Contract. And that, again, kind of comes back from my experience. As I mentioned, I particularly focus in the world of Spring on it. So that kind of naturally just brought me to use Spring Cloud Contract when I started getting into contract-driven development. But why should you consider using it? Not just because that's just what I kind of gravitated towards because of my background. Well, there's several advantages to using Spring Cloud Contract. One, it's a very active project. It's not like they only do like a couple of changes like a few years ago and it's been kind of dead since then. It's ongoing and being actively developed and changed, and it's open source, so you can also contribute to it and then also put issues into it to have it changed to meet your needs as well. So it's ongoing and actively developed, so that's always great. It's also interoperable with other tools and standards. So like you have OpenAPI, Pact, Swagger. Some of these are just about defining APIs. Other ones like Pact are other choices for doing contract-driven development. But all the same, if you kind of already went down the route of using these technologies, it's not like you have to throw them all out now because you decided to go with Spring Cloud Contract. You can actually still leverage your existing work and maybe slowly migrate over towards using fully Spring Cloud Contract. Or you can just kind of work with them both at the same time and then, just work with them in parallel. It's also really nice, flexible documentation support with Spring REST docs, which is backed using ASCII Doctor. And I feel like it gives a very nice presentation to the documentation, which kind of maybe also goes back to that earlier thing where we were talking about how I kind of mentioned maybe like the documentation is in Word or PDF or something like that, which isn't always the easiest documentation for describing programming concepts, but it can be really, but having something like ASCII Doctor usually works a little bit better, has better support for displaying code, for example. Lastly, and this is where the collaborative part of contract-driven development comes in, it has really great polyglot support, which I'll touch on here in a few moments. All that said, you can check out the official documentation for Spring Cloud Contract for much more in-depth documentation. But what do these contracts look like? So I kind of talked early on about what contract-driven development is. What do these contracts look like for defining this interaction between clients and developer and the backend service developer or backend service? And so this is an example. There's several different ways to write contracts. In this example, this is Groovy. There's also YAML, and I don't have an example of it, but there's also Kotlin. But both of these contracts, so the Groovy and the YAML contract example I have here, are describing the exact same interaction. There's no real limitation to which kind of DSL you want to use. It's just a matter of maybe what works best for your organization. In this example contract, though, it's an extremely simple contract, just defining interaction of adding a new person to a person service. And you can see here, we're defining the method type, a post, which endpoint it's going to, API persons, what the body looks like. In this case, we're expecting two name fields, F name and L name, with the values of John and Doe, and then a couple of headers like for the content type. So if I send a request like this to my service, then I would expect back a 201 response created in for HT response, and then also the location of this new person's object. And again, we see this here as well within the YAML contract, all those kind of same concepts explained out. So along with so about 2 years ago is when Spring Cloud Contract gave really good formal polyglot support. And along with that is before you would have to have a lot of Java specific tools and knowledge. So like you would have to have the JDK installed. You had to understand either Maven or Groovy to configure Docker or to configure Spring Cloud Contract to run. But to actually properly support polyglot ability, which is really important because your client developers probably aren't going to be Java developers. They're probably going to be JavaScript developers, or they could just be anything else because it could be also some other Java service running on the other side, or C# servers or whatever it might be. But they're not going to have all these Java tools on their side. So they needed to make some changes to be able to properly support them, because expecting non-Java developers to understand all these Java tools is a bit too much. So to that, they created some Docker images that encapsulate all the Java and Spring Cloud contract logic within a Docker container. They have images for both consumers and producers, which I'll touch on a little bit later. But you configure it by passing in some environment variables to describe like, hey, where are you going to get these contracts or stubs from? What port you're going to run this on, and a few other things to be able to be able to run these to be able to run the contracts or the Docker images. But with this all, you now have proper polyglot support, because now you have tools that are pretty independent of the type of developer. Before, like a Java developer, as I mentioned, they would have JDK, Maven, a Java-friendly IDE, but that can't be expected of JavaScript or other developers. But now Docker is becoming a pretty ubiquitous tool that all developers will have installed on their system. And of course, all developers, by their nature, will have a text editor or IDE installed on their system. So anybody can really be able to write contracts, test them, and use them. You're not going to, again, have to learn about a bunch of other knowledge that's kind of going to be outside of your domain. But what does this all kind of actually look like? There's also a couple different practices for how you write contracts. There's production-driven contracts. And when that happens is the service developer that's actually writing the service that a client will be connecting to, is that they will write out a contract and they will say, and it'll be like, hey, the API will look and behave like this. And of course, as a client developer, that's good because you actually will have this contract that will be tested against the service. So you can have confidence that this contract actually describes what the service will really look like. And client developers like, okay, that's great. You can also have consumer-driven contracts where the consumer says like, hey, this is some kind of new behavior, new features I will need from this service. Can you write this for me? And the service developer is like, okay, again, because this contract describes everything, they can actually properly write it out. It's not like a vague, hey, I need a service to do this, and this is kind of broadly sketched out. They actually have something they can write and test and build to, versus just a very vague idea or concept. But when it comes to producer versus driven contract summary, a producer-driven contracts idea is like a push model. They're pushing out changes. They're pushing out what this service is going to be doing. Consumer-driven contracts is a quote-unquote pull model where they're kind of pulling the service into the different forms and ways that they need it to look. But functionally, the contracts, you can still store them in an agreed upon location within your organization. It could be a repo that's just devoted to contracts. It could be stored on the producer side with the producer repo. It doesn't really matter where. And also the contracts be functionally identical. Just looking at the contract itself, you can never know if it was a producer-driven contract or consumer-driven contract. It's just like the overall concept of how it's actually written in your organization. Just like you can't look at code and be like, oh, this is written with agile methodology versus waterfall or whatever it might be. The code functionally will look the same. So in this case, It's not like when you're doing producer-driven contracts, you're only modeling the response, and consumer-driven contracts, you're only modeling the request. You would still always remodel both the request and response, regardless of what kind of overall model you have for writing out contracts. But then how this would all work is you have your contract written, and then you would actually test your service to make sure that it actually meets the requirements within that model. Going back to like the example I have, you would test the service with this add new person contract, which I showed a little bit earlier, to say, okay, does that endpoint exist? Is it a post? If I send it a first name and a last name, will it respond with a 201 saying, okay, it created it? You can also, as I mentioned, to have that proper polyglot support, you can do this using one of the Docker images that the Spring Cloud contract team created to test it as well. It doesn't have to be configured through Maven or Gradle within your Java service to be able to test it. Again, I'll touch on that in just a few moments. But once your contracts are tested and they all pass, Spring Cloud Contract can also create a stubs artifact, which then can be used as a stand-in for those service or for those contracts. And then that stubs artifact can be shared in your artifact repository. So this can be very helpful for if you just want to have a stand-in for those contracts, or you want to have something that you know that has actually been tested against a service that actually works. You can also then share it then with third parties that maybe are outside the organization so they can develop and test to see if they can consume and properly work with your services without maybe always having to have like a bunch of different test regions for them to work with. Also, as I mentioned, you can create, it has support for documentation in Spring REST docs. So from these contracts, you can actually generate documentation on how this API works. And because this documentation is actually being part of your automated process and won't be actually written until these contracts actually pass, you have confidence that this documentation actually matches with the current behavior of the API. It's not like we wrote this documentation once we finally went to production and we haven't updated it in 3 years, so who knows if it actually matches. Whenever you're making changes and updating the API, the contracts are going to be testing the API to make sure they actually still match. And if they do, then that documentation is going to be generated. So the documentation to always closely match whatever the current version of the API is, of the services. And then lastly, so now you can have your clients, again, test against that stubs artifact as a stand-in versus testing against that service, which I kind of mentioned early on, could maybe be down, could have some of its own issues with it, but they can test and work against that as well to make sure that their service or their client service that's going to be using it can actually properly consume it. And as I mentioned, you can also use the Docker images as well. You don't have to configure and work with Java to actually use Spring Cloud Contract. And another change, which I'll demo here in just a few moments, you can also just do it directly from the contract. You don't necessarily have to use a stubs artifact, and I'll kind of go a little bit into why that can be beneficial. So just to quickly review what we just covered, so you would write the contracts to define the behavior of the API. So contract-driven development, you write the contracts before you actually start writing out the API. Then the contracts validates that the API matches that behavior. You will bundle the contracts in a shareable artifact. You can generate documentation from the artifact, and then of course the clients can then test and develop against those artifacts. But crucially, those last 4 elements, obviously except for the part about clients actually doing development work, but all of them should be part of your automated build and deploy process. So that way it's being checked every time and you're not running into issues like, for example, in that last scenario, as someone changing a service, like the endpoint or something about that service that would then cause a change that breaks, that gets to production, that should be caught by the contracts because the contracts haven't been updated. So I've talked about this. Let's actually kind of see this in practice now. So I have a simple demo project, produce service. It's kind of a play on the fact that the 2 common terms when talking about contract-driven development is producer and consumer. And so I have then also Let me. So I have this produce service, and then I've written for it out on my GitHub repo some simple contracts for it. So I have 4 contracts. One contract is adding a new item to this service. So add produce. Another one is an example of trying to add a new item, but it's missing some required fields. So in this case, it's a fail. So also contracts aren't just limited to describing successful interactions, but you can also, and you should describe it for unsuccessful interactions. So like what happens is someone doesn't send like an authorization header, or in this case, doesn't send a required field. What should your contract or what should your service do in that case?
Hey Billy, can you please post the GitHub links in the chat or somewhere?
Yeah, I will. Yeah, I'll
Okay.
post these in the chat. It's also in the
description
slide deck that I have as well. Yeah, so yeah, all the same, we'll get you all the information you need so you can kind of check this stuff out yourself.
Awesome.
In this contract, we're just doing a simple get just to get like all the different resources out of that container. And then maybe also doing a very specific search for certain kinds of items to get out of this service. So all the same, we have 4 different services here, or 4 different contracts. It's kind of defining some simple behavior for this service. So then here, within this project, I can just do a Maven test, and we can actually see this. It'll take a few moments, but it'll then run through this test. And we can see here 4 contracts, and they all successfully passed. And so how this works, in this case, I'm not using the Docker images. I'm just using the configuring it through my Maven file. Let me get that larger. I have a plugin here that's defining the Spring Cloud Contract Maven plugin. I'm telling it here to use the Git repository that I just showed just a few moments ago. And also here, I have like a base class where I'm kind of mocking out the behavior of what my service should do when it is being tested by the contracts. So one of the really important things here is to make sure that this base class that you're using to simulate the behavior of service actually properly simulates what your service would actually respond with, because if you do this incorrectly, then you may not be getting the results you want, where you could have your service behaving one way in reality, but this base class tells it to behave a different way, and then you're not going to get the correct results back. So it's really important to make sure that this service or this test class or classes you have set up properly model what your service would do. But in this case, like I'm using Mockito to do a bunch of things. But that's just one of the important things to kind of keep in mind as you're doing it, is to make sure that this properly models what your service would do. Lastly, I also mentioned the documentation support. So I also have ASCII doc, to where once all the tests have been completed, it will write out this documentation based upon the contracts. So it's a few steps of setup you need to do. So for example, here I have this ASCII doc file that kind of tells it where to go and look for all these contracts, and I'll pull in this information. But once you kind of have that all configured, every time this test, or every time I run a Maven package and it goes through its full cycle, I get this new generated documentation. Whoops, I don't want to do it that way. We want to actually see it being rendered. There we go. So I get this generated documentation that is describing how this service works. And again, because it's based upon those tests that just actually run, and this wouldn't be generated unless all those tests pass successfully, you can have a lot of confidence that this is actually matching what the current existing service looks like. It's not like what it looked like when it was first went to production, however long ago that might be. And since then, like new fields and new headers and new other things have been changed and added, and it's no longer up to date. One other thing I just want to quickly show, just so you can actually have confidence that it's actually testing the service. Let's get rid of that. So let's say if I go in here and I just change it to produces instead of produce for this, and I run all those tests and I run Maven test again, all those tests are going to fail because I changed the endpoint and that's not what the contracts are expecting. So it looks like I have a few for executing. So in this case, so within a Docker image, which I'll show here in a second, you can kind of find where those port numbers are. So for like doing a token or something like that, is you would define it within the contract. So like we have like the response and status and headers, you would put in here a header that would be like your authorization, and you can have an example of like what a JOT token will look like. And there's a couple of examples out there of doing that specific thing using a JOT token, or just a JOT, I guess, kind of like ATM machine. But a JOT to test that kind of behavior to make sure your authorization is there and it looks at least generally like what you're expecting. As far as this, the port numbers and stuff like that, when you're working with it within Java, it's all kind of like random, and like the internal logic within the Spring Cloud contract Maven plugin knows like which port that has been spun up locally and then tests against that. Now, if you're doing it using the Docker images, you would actually define that. And I can show an example here. And we'll actually also run this example here in just a few minutes as well. But you would actually here, like I'm defining that it's going to be this 9876 is defining the port number that it's going to spin up the mock service on, or you can also test against. And in this case, I'm also providing a pass-through within the Docker image to make that port public. But that's how you would define it within a Docker image, by passing it in the environment variables. But let's also then see using these Docker images, and yeah, that's not what I wanted. So also one thing I mentioned is that a change they made about a year ago is before you would have to wait until that stubs artifact. So at the end of the build process or the Maven test project or Maven test, they would create a bunch of stubs. So like here you'd have this stubs jar, and what's in this stubs jar is a bunch of JSON files, because the underlying way that Spring Cloud Contract would provide a mock service is through a tool called WireMock, which consumes JSON, which again describes this behavior. But before, you would actually have to create this stubs artifact for your mock service to run. But recently, or about a year ago, the Spring Cloud Contract team allowed it to where you can just write it just off the contracts themselves. And why this is nice is if you're doing consumer-driven development or consumer-driven contract development, it allows the consumers to write out a contract and then start testing against that contract while they eventually wait for the producer service or the producer developer to actually implement it. So now they don't have to like write out a contract and then maybe wait a week or two while the backend developer actually implements that behavior. They can actually start and test that now. And we can actually see expand that. But here again, I'm just saying, okay, this mock service is going to be running on port 9876, and I'm telling it to go out to that Git repository to get that information, to get those contracts. And in this case, you have to then also set to generate stubs to true, and then it'll run the mock service, which I'll demo here. The other way of doing this, though, is in this case, I would be pulling, so like this stubs artifact, you would put it into your Artifactory or Nexus or whatever your artifact repository. I'm defining here a local Artifactory that I have set up. And again, I'll be pulling this from a remote location. But that's just two different ways. The one beneficial way of doing it from the stubs artifact is by the time the stubs artifact is created, then you know that the service is actually implementing and following the behavior of the contracts. Whereas if you're doing it just from the contracts themselves, there's no guarantee that the service is actually following those contracts yet. All the same, we can actually see this in action then. So I'm setting this up. And I'm also going to just go in and run this service so we can kind of see it in action in parallel. And actually, I need to go back and change this.
Billy, I'm not sure if you intend the audience to read this, but if so, can you please increase the font?
Yeah, this part of here isn't too super important, other than it's code that's starting up. But all right, so all the same, I have like the quote unquote live service running on port 8080, just a standard Spring Boot port. And then I also have a mock service of this running on port 9876. And I'm just going to kind of compare just calling the two of them. So here I'm calling the mock service. It is a bit hard to read, but in this case, I'm getting back just a JSON response back. Let me call that again. So yeah, I'm getting a JSON response back. I'm getting 4 items back. You can see ID 1, 2, 3, and 4 here. And I'm always going to get this response back because it's mocked out. It's based upon what those contracts are I have defined. So I can get a reliable test from this. Of course, you can write tests to be a little bit more flexible, so where if one of these items goes missing, it's not going to fail. But all the same, that's a constant issue you kind of see with automated testing, is like maybe some test data goes missing and all of a sudden the test is failing. But it's not really failing because like the API changed. It's just like some of the data I was expecting in its test has gone and changed. And we can kind of see that here where if I call the quote unquote live service of the actual Spring Boot application I have running, and oops. So here I'm calling port 8080, whereas in the previous one I'm calling port 9876. I actually get back 5 items. Like there's like a new item that was added to this list of items I'm getting back. And again, you can write automated tests to where it wouldn't necessarily break because of this. But all the same, this is just kind of showing how when you're testing against a live service, data can change. And, that could lead to test failures. Of course, also maybe like the backend database, like I showed in the earlier scenario, failed. And now all of a sudden this test is failing because this code failed because that service is down, but not because something actually changed within the API. So that's just like a brief demo of what Spring Cloud Contract looks like. Let me and actually put together a quick lab here that kind of is a little bit simplified version of what I just showed you. You can go through. Well, I was saying, let me kind of just summarize this all up. So just some quick final points. So in this demo, I was showing all using like REST and HTTP, but you can also write contracts for messages, or you can, write it for more posts, or it doesn't have to follow like strict whatever is RESTful guidelines. It's much more flexible than that. It's also okay to change contracts. So, within at least American nomenclature, like, contracts are written in stone, i.e. they're inflexible and unchangeable. And that's not the case. So, of course, once you actually get a service pushed to production and it's public and it's being used by other people, you want to be careful about changing that. But during the development process, it's totally fine. It should be expected to maybe change the contract because maybe that behavior you've defined just doesn't really make sense, or it doesn't work as you're expecting it. So it's fine to change contracts. Also, contract tests, they're just part of an automated test suite. They're not meant to they're not acceptance tests, or nor do they replace like end-to-end tests. They're just part of your automated testing suite. So things you can't really test, like resiliency, timeouts, performance, edge cases, and so on. Like I said, it's just part of your automated testing suite. It's not meant to replace everything. It's just narrowly testing that integration layer, making sure you can actually properly communicate and work with some sort of API. As mentioned, and I'll go ahead and post this in, here, let me get out of there. I will post this into the chat, but I put together a quick lab. Maybe take 10 to 15 minutes to complete. And also the code I just demoed, is also here as well. So you can check those out. But definitely check out this quick lab. It should, here it is. It should look a screen something like this if you're already signed up, hopefully, for our Skills Network lab. But it's 6 steps. And like the first one, you kind of started off with like how you would validate to make sure like your service is actually meeting those contracts. The next one is just kind of like updating just to make sure, like, because initially like the contracts are going to fail because if the service isn't fully implemented. So we're going to implement something just so you can see that actual contract-driven development process. Created your own contract and then running that mock service like I did there at the end. But yeah, definitely check this out. Hopefully, I just ran through it a few minutes ago, and I think all the steps properly work and everything. But if they don't, let me know. I'll be happy to help you through it. But with that said, yeah, definitely check this out. But if you have any questions, let me know. I'll be happy to answer them now.
Billy, so there are 2 questions in the Q&A area. I don't know if you have access to that on the other monitor.
Yes.
Okay, great.
So yes, yeah, that's it can be implemented in any language. So the contract, you can't write it in JavaScript. So you can like I said, mentioned, like you can write it in YAML, you can write it in Groovy, you can write it in Kotlin. The lab will, there's no end date on when the lab won't be available. So yeah, definitely no rush to do it, North Dakota. But yeah, as far as implementing it, like what the behavior defined within the contract, you're not limited to any programming languages. So what benefits do you see CDD can bring to? I haven't really worked too much with gRPC services. You don't have to follow RESTful behavior. Again, a contract can be defined for any sort of behavior across HTTP, which I believe gRPC is still using, unless I'm mistaken. So you would still get that benefit of being able to mock or test a gRPC service to make sure that it's actually meeting what your expected behavior is, or serve as a mock for an example of it. To your question, Norbert, no, like that's not the goal of like expected response time or any sort of like functional stuff like that. It's just kind of testing that narrow integration layer. Can I properly kind of work with this service? If I, send the correct information or maybe I'm missing information, do I get that certain kind of response back? So GraphQL, it's all doing kind of post. So again, you could maybe kind of write a contract out based upon a GraphQL service, but like GraphQL kind of like has some of this stuff already integrated with it. I'm not by any means a GraphQL expert, so like I think you could, but I think that's also kind of covering some of the stuff that GraphQL is kind of wanting to do anyways. So I don't know if it would really make sense if you're using GraphQL to use something like Spring Cloud Contract in that context. Cool. So like I said, definitely check out the lab now if you want. But if you end up having questions, you run into some sort of issue, definitely feel free to reach out to me on my at my email or at my Twitter, and I'll be happy to answer any questions or help you through any sort of issues you might have gone through. Can they be dependent upon each other? So like you can be ordered, like do the step first and then do the step second. I don't believe they can be. Now there is what's called, and any way to, so how you would maybe do cleanup and reset data between tests is, sorry. So within this base test class is kind of how you can maybe clean up that data between tests or stuff like that to make sure that it could actually work properly. But as far as I know, there isn't a way to order the execution of the test unless it's been recently added or create some sort of dependency. They're all kind of all dependent on one another in that if any of the contracts fail, then overall that's just going to lead to like that plugin failing because it's expecting them all to pass, but there's not like a step 1, step 2, step 3 capability as far as I know. One of the things I do kind of point out in the quicklab though is so here both of these contracts are both doing a post to the same endpoint. So here you can see post to API v1 produce, and that was the other one was doing. In this case, one is doing like a successful post, like successfully adding something, and another one is doing something when, in this case, like the name field is required and it's not being passed in there. You can add priorities to them, and it goes by reverse value. So priority 1 would be the highest priority, and you can keep adding priorities, as far as I guess as high as ints go. If you need like the 1,200,000 some odd different contracts, hopefully you don't. But all the same, I think it's just like an int value, so you can keep adding to it to test like the same endpoint. So yes, kind of what you're talking about. So there is flexibility and stuff like that. I don't have an example here, but there's some examples to where the request could be like you're sending something in, and you can then say like the request, like you can tell it to match to some value within the request body that it could be maybe modifying it or something like that. But again, that would only be within the single contract. You can't maybe, there is a decent amount of flexibility and dynamicness that you can add to these contracts. But like, you can't be like, oh, based upon this other contract, add something to it. Like, I don't think that would be quite allowed. I haven't quite tested that, but I'm pretty sure all these contracts are independent of one another, and there's no guarantee on the order the contracts will be executed. It does. Yeah, JUnit 5 does have support for ordering tests. I actually kind of done that stuff as well. Okay, I guess that's just maybe saying something. Yeah. Yeah, but even though, yeah, JUnit 5 offers support for order tests, I don't know if there's a hook in yet between that order test and linking it back to these contracts as well. But if there isn't, I would definitely recommend well, say you can go here and ask for that to be implemented, because when doing integration testing, you know, it can be actually appropriate for there to be relationships between different tests. It's not like unit testing where they should be completely isolated and independent of one another. It's kind of fine that there could be some relationship between the different tests. So if that support isn't there, and again, to my knowledge, it isn't, but, you know, verify that. Definitely you can try submitting a feature request for that, and maybe that could be added in a future version of Spring Cloud Contract.
So I see lots of great questions, Billy. I'm wondering if anybody tried to open the lab and if you were able to get in. I'm just curious if anybody was able to, or if you have any questions, or sorry, if you had any trouble logging in, just getting the lab page up, you can address, maybe you can ask us now.
Yeah, definitely, yeah. Let us know now. And also, there we go. I'll try to get a more human readable link, but all the same, that's a link to this slide deck. Yeah, you can only view it, but that way you can kind of see it there as well. Yeah, but you're not, are you really, like, the point of Spring Cloud Contract, because like what are you really testing there? In that case, you'd just be testing the actual backend service to see it does something, but that's not really testing anything about the client to make sure it can actually interact with that service. So, because as I mentioned, you would be kind of simulating in whatever contracts base class here, you would be simulating what your service would be doing. So kind of what you're talking about here, you'd only be simulating within this contracts base class, like, oh, okay, I should have an extra service now, or an extra item, and then returning that. So you're not really getting anything out of that in that interaction of, can this client properly interact with this service? So, I mean, that can kind of that makes sense. Some integration tests, like maybe working with a database or something like that, to make sure, like, I added an item and and then maybe getting like a result back saying like, okay, yes, I really successfully added that item to that database because now there's 6 items as it was before it was 5, but that's not quite the interaction of the goal within contract testing. Another person, I mean, again, maybe that should be added, and that's just my interpretation of it. But the lead on the project is Marcin, and I'm not even going to attempt his last name. You can find him on Twitter here. He's very helpful and responsive. You can maybe kind of ping him with a question about that to see if that would kind of maybe make sense as a future add to it. But again, it's not quite the interaction you're expecting from Spring Cloud Contract. So. Yeah. And yeah, has anybody tried going to the quicklab just to make sure it can be successfully got to? I'm not like logging in with my own ID. I have access to it. So that would be good confirmation if anyone has a couple of moments to check that out.
Yeah, I was able to, but
okay, good.
It would be nice to see some. And I didn't go through. Sorry, I didn't use the IBM thing. I used my GitHub. I was able to log.
Okay, good. So it's not like only accessible to IBM people or the course author. So that's good to know.
Yeah, excuse me. I really like how the lab is built out, where I can git clone and start working and start copying stuff. It's really well done. Thanks, Billy.
Yeah, absolutely. So we have one more question. So contracts are written for each. Yes, basically, yeah. Or you would write tests for every kind of interaction or behavior you would expect from a service. So, like if you don't have like a put at an endpoint, like you obviously want to write a contract for that put, but like also for like this post, like I have multiple contracts associated with this post endpoint. Again, this one being a successful call, another one being an unsuccessful call. But you may have more, like a bunch of different calls that are associated with an unsuccessful call. Like, for example, with a post, maybe you are trying to add a duplicate item, in which case you would define yet another contract, even though it's for the same method, and maybe it's also defining an error, but you would have a different kind of error saying like, hey, this item already exists in the service. And that way, maybe the client would react differently based upon that kind of response. So like I said, you will have a contract for every different kind of behavior within that. And also wise, do so a separate contract in every file. You could put multiple contracts within the same file. So if I just, like in YAML nomenclature, if I did like 3 hyphens, I could put like another contract in here as well. If you just kind of want some sort of logical relationship between contracts. Yeah, thanks, November.
All right, I think we've gone, excuse me, a little bit over time here, but great discussion.
Yeah, thanks for all the questions.
Again, thank you for joining us today. I'll send out an email after, excuse me, my throat. I'll send out an email after we're done here with all of the links that you shared, as well as the replay that'll be available on the same URL here. So for people who couldn't make it, they can at least watch the replay. And again, thanks again for presenting with us today.
Yeah, thanks for having me, Upkar, and thanks for everyone joining, and thanks for all the questions. It kind of makes me feel good. So I'm not just shouting into the void. I actually really always like having questions. So yeah, thanks again.
All right, bye-bye.
All right, bye.